All right, 2007 E&M number 2. We have two concentric spherical shells that are non-conducting and have, well, the inner one has a plus charge uniformly distributed throughout the volume. Okay, that's not that bad. But then the outer one also has a uniform charge of minus Q distributed throughout its volume. This one is going to be annoying because we're going to have to subtract out that space of radius 2a from the inside where there's no negative charge. All right, part A. Using Gauss's law, drive expression for electric field for each of the four regions. Inside, between, inside, and then outside. All right, inside we have charge spread uniformly throughout the volume. So A1. Q enclosed over epsilon naught equals integral E dot dA. Now for all of these guys, the area is going to be 4 pi r squared. That's not going to change for all of them. It's just what are the limits on r going to be for what we care about. Q enclosed is going to be the one that changes based on where we're looking. So for part 1, within the sphere, we need to have a volume within the sphere. So this volume here, we're going to have 4/3 pi little r cubed, and that is going to be related to 4/3 pi big R cubed because it is uniformly distributed. So the ratio of little charge to little volume is going to be the same as the ratio of the big charge to the big volume. Now we can cancel out these constants here and here, and substituting for Q enclosed and substituting for the area and rearranging, we can get the electric field to be 1 over 4 pi epsilon naught Q over r cubed, and then these r cubed and that r squared are going to cancel, and we're going to get just plain r. For part 2, okay, between the spheres. So if we draw our sphere, now between them we've enclosed all of the inner ball of charge and none of the outer ball. So Q enclosed is just going to be the total inner charge, and we have the same area. The electric field then is going to be 1 over 4 pi epsilon naught Q, and then our variable r now is going to be in the denominator. All right, number 3 is going to be a nuisance because number 3 is where our Q enclosed is going to be all of the inside and then part of the outside. So if we draw our sphere, a Gaussian surface here, you can see that part of the negative charge is inside the Gaussian surface, part is not. So our enclosed charge is going to be all of the inside and then part of the outside, and the outside is negative, so we're going to have a minus sign here. So this is going to be the ratio of, this is a nuisance. Q, and then we're going to have 4/3 pi r cubed minus 4/3 pi, that's 2a, so that'll be 8a cubed over the total volume, which is 4/3 pi, well that'll be 3a, so that'll be 27a cubed minus 4/3 pi 8a cubed. You have to keep in mind the total volume of the spherical shell is the 3a radius minus the hole in the middle, which has a radius of 2a, which we then have to cube. And then the actually enclosed volume is going to be, where did I draw my spherical shell, minus the big hole in the middle. Notice how this is the same ratio as we have here, where Q enclosed is going to be Q and then the enclosed volume divided by the total volume. So we have the enclosed volume divided by the total volume, and once again, all of the 4/3 pi, 4/3 pi, 4/3 pi, and 4/3 pi, they all cancel out. Now what we have is a ratio here where we have this guy's r cubed minus 8a cubed, and this is 27 minus 8 is 19a cubed. So we're going to have, once we do a common denominator here, we're going to have 19a cubed minus, well, it'll be plus 8a cubed. So that'll be 27a cubed minus q times r cubed. That gets us our enclosed charge. Fortunately, 4 pi r squared is still the same. Combining all those guys together gets us an electric field of 1 over 4 pi epsilon naught. And then we're going to have Q over 19. And I've rearranged things on my answer key here. So we're going to have a 1 over r squared. That comes from this area here. And then inside our parentheses, we'll have 27 minus r cubed over a cubed, which is where this a cubed, it just got all grouped together down here in this a cubed. Yeah, I think that's kind of ugly also. And it's entirely ugly because of this giant hole here. All right, part 4, outside. So once we take a look outside and we draw our spherical shell out here, we have a plus q, and we have all of the minus q, so our q enclosed for 4, where am I going to put that? Let's get rid of this for a second. So 4, q enclosed is going to be 0, which means that the electric field is going to be 0. All right, that's a bit of a pain for all of part A, which turns out to be a lot. I'm going to have to clear all this out in order to figure out B and C. All right, part B. What is the electric potential at the outer surface? So at the outer surface, we have enclosed 0 charge. So V equals KQ over R. This is for spherical distributions when you're outside the sphere. So at the outer surface, we're outside the sphere. And that means Q is equal to 0 because we've enclosed a plus charge and a minus charge. You could even visualize this as an atom where we have a nucleus surrounded by a cloud of electrons. Outside the atom, it's electrically neutral, so that means that the voltage is going to be 0. For part C, we want to have the electric potential difference Vx minus Vy. So what we want is Vx and Vy dV, and it makes sense for us to use the integral of E dot dr. Don't forget the minus sign, that's part of the equation. And we want to start on y and end at x. So we're going to start at 2a, r equals 2a, that's where y is. And we're going to end on x, where r is equal to a. And this is in the nice, pretty place where we've enclosed all of the positive charge and none of the negative charge. So our electric field is going to be Q over 4 pi epsilon naught 1 over r squared. Then we're going to have our dr, integral, and a minus sign. So all of these guys are constants. They go along for the ride. And when we integrate this guy, we get a 1 over an r with a minus sign, but we have another minus sign there. Oh, goody. And we're going to go from 2a to a. And that gets us on the left side Vx minus Vy. And when we plug these guys in, we're going to get, again, the constants go along for the ride. And then we have 1 over a minus 1 over 2a. Cleaning this up a little bit, we have 2a minus, nope, that's just 2, minus 1 over 2a. So that'll be 1 over 2a. So the potential difference between x and y gets us q over 8 pi epsilon naught a.